Thank you for taking the time to reflect on what you've done so far. Being able to teach others about what you've built feels rewarding, but it's also a core skill in being able to communicate with teammates that you may work with on a software project. With that in mind, let's keep moving forward so you can go back to those people soon and share your progress. So far, the functionality of the quantity picker in our app is working well. So now we can spend a little bit of time making it look a little better, a little sexier. We want to move closer towards our end goal. This is what we have now, and this is what we want. The buttons in our app currently work, but they're not in the ideal layout. This layout leads to a better user experience because we're going to be adding more fields to the order form in Lesson 3. With this layout of the buttons, it's easier to scan through the list of fields in the order form quickly. In the current layout, if you want to scan through the form quickly, you would read quantity plus 2 minus price and so on. So it's faster to scan through the form if the buttons are laid out like this. This updated layout also takes advantage of more of the horizontal space on the screen, instead of squishing everything into a very narrow vertical column. The challenge becomes identifying the gap between what we have now and what we want. Can we repurpose the views that are already on screen and move them into the new position for the new layout? Or do we have to add views or remove views? Before we get lost in the details of changing the XML, I want you to first plan out how you're going to approach building this layout. In your own words, describe your thoughts on each step that we've taught you for how to build layouts. You don't need to write XML at this point, you can just plan out your strategy. These notes are going to help you actually write the code at each step, so be as detailed as you want. The first step is to select the views. Which views are you going to need in terms of text view, image view, button, etc.? The second step is to position the views. Can you describe how these views are positioned on the screen? Which view groups are relevant to building this layout? Step 3 is to style the views. Is there anything we need to do to change the visual look and feel of each of these views? When planning how to build this layout, we're going to start with the assumption that we're going off of what we currently have in our app. We're not building this from scratch. For step 1, selecting the views, we actually already have all the views that we need. There's no need to add or remove views. We should have 3 buttons and 4 text views in our layout. For step 2, positioning the views, I first describe what the layout looks like to me. I see a header followed by a row of buttons and a text view. Then I see another header and another text view. And lastly, that is followed by an order button. From this observation, I notice that we can't just use a vertical linear layout because this item here is made up of more than one view. We could potentially consider relative layout, but I'm going to leave a question mark by that. For step 3, we want to style the views. The style actually remains pretty much the same as we had before, although I do notice that this quantity value has a little bit of space between the minus button and the plus button. So we might want to achieve this with either padding or margin around this text view. When discussing how to position views in the last quiz, you may have mentioned using a relative layout. I know we did, but I want to introduce you to another way that you can build the layout for our app that would be more ideal using nested view groups. Nested view groups means putting view groups inside other view groups. That way you can build more interesting and complex layouts like these. Let's see how you would build up one of these layouts. Say for example you have a vertical linear layout with 3 views, an image view and 2 text views. What if you wanted to overlay some text on top of this image? Well, with a linear layout you can't overlap views, but with a relative layout you can. So we can replace this child with a relative layout instead. Then we can put the image view inside this relative layout. This image view is now aligned to each edge of the parent relative layout. So there you see an example of a relative layout that's contained within a larger linear layout. You can have many combinations of view groups within other view groups. For instance, you can have a relative layout as a root view for an app. That can contain a couple of views like an image view and 2 text views. You can also add a linear layout as a child of this broader relative layout. This linear layout itself can contain other children, like 2 image views. You can nest as many view groups inside other view groups as you want. However, be careful because the more nesting that you do, the more expensive it will be for your app to lay out on the screen. The relative layout in particular is a very flexible layout, but it can be very complex to calculate the position of each of these views relative to others. So it's recommended to not have too many layers of nesting within a relative layout. I pulled some examples from real-life Google apps to show you some cases where it would be useful to use nested view groups. The Google Now app shows you cards of relevant information based on your current situation, like the current time or current location. If you like a certain team like the Red Sox, good choice, then it can show you the score for the latest game. To build out the layout for this card, you can imagine using a vertical linear layout because the information is displayed as rows. However, the first item in this vertical linear layout is not just a single text view. It's made up of multiple views. In fact, you would build this first item as a horizontal linear layout made up of an image view and 2 text views. Same for the second item in this vertical linear layout. You would build it with a horizontal linear layout containing an image view and 2 text views. Another card in the Google Now app shows relevant stocks that you may be interested in. I wish the Google stock was still at that price. Anyways, you can also build out this layout as a vertical linear layout because you can imagine the rows here. Except these middle entries aren't just a single text view, they're made up of multiple text views. For this line item relating to the Google stock price, you could use a horizontal linear layout and fill it with 4 text views. Same for the other stock prices as well. These horizontal linear layouts are children of this broader vertical linear layout. In the Google Play Music app, you can of course listen to music. While this looks like a complicated layout to build, you can actually break it down into smaller view groups that you recognize. This pattern feels like a vertical linear layout with 3 different children. This first child can be built using a relative layout because the views are relative to each other. This second child can also be built using a relative layout because the views are overlapping each other. And this third child here looks like a horizontal linear layout made up of 5 different buttons. Again, we can use nested view groups to build out this screen. This is just one way to build out the layout. You can build it in many other ways as well. In the Google Maps app, earlier we saw that there are detail pages for individual locations, like restaurants. You can't build out this screen with just a single linear layout or a single relative layout. You need to nest a bunch of view groups together. On a broad scale, we can see that the information is almost organized into rows, so we can use a vertical linear layout as the parent view. One child could be this whole layout here, another child could be this row of buttons, another child would be this description, and so on. But within each child, it's not just a single view. We have multiple views. This child in the broader vertical linear layout is made up of 3 individual views. So you can use a horizontal linear layout with equal weights to each view so that they get spread out evenly. This child in the broader vertical linear layout can also be made up of a horizontal linear layout with an image view and a text view. If you keep scrolling this page, you see more information on the restaurant. Again, I can imagine the individual rows of information here. Using a vertical linear layout for all this information still works. And again, some rows are more complex than just a single text view. This row shows a bunch of available times where you can make a reservation, and it's made up of 3 different buttons that you can arrange using a horizontal linear layout. This row of pictures can be built using a horizontal linear layout as well. And actually, within this horizontal linear layout, this first child is not just a single image view. It's an image view with a text view. So you could use a relative layout to build out this first child. So you can see how there can be view groups within view groups within view groups. There's actually more view groups beyond just relative layout and linear layout. There's also frame layout and grid layout. We're not going to have time to cover those in this course, but I definitely recommend that you go out and learn about them on your own, because sometimes those would be better than just using a relative or linear layout. Let's look at how nested view groups would apply to our app. The information in our app looks like it's arranged in a vertical column, so we can use a vertical linear layout for this. This looks good so far because we have 1 view per row in the vertical linear layout. But when we get to this row, it's actually made up of multiple views. We can use a horizontal linear layout to build out this row composed of a button, a text view, and a button. So this linear layout would be the second child in the bigger vertical linear layout. In a moment, I'm going to show you 3 different XML layout files, and I want to ask you which one you think accurately builds up the layout that we want. The catch is I don't want you to copy these files and run them in Android Studio. I want you to make an educated guess based off of reading and understanding this code. You can find this link in the instructor notes. It has 3 options listed: Option A, Option B, and Option C. One of these options correctly builds out the layout that we want. This is going to be challenging because we haven't previously encountered XML with nested view groups. We're going to split this challenge across 2 quizzes, so I won't ask you to make a decision yet. For this first quiz, I want you to sketch out the view hierarchy diagram for each of the XML files. Here's a quick spiel on what view hierarchy means. You'll need paper and something to write with in order to sketch out these diagrams. The way that Android organizes all these views on screen is in a view hierarchy, or a tree structure of views. This is simply a diagram that represents the view hierarchy. It shows the parent and child relationships among the views. The root view of this whole layout is a linear layout. It has 3 children, a relative layout, a text view, and another text view. And then this relative layout in turn has its own children, an image view and a text view. For our Puddles the Pig app, this is a view hierarchy that gets created by Android. We have a relative layout as a root view, and it has 4 children, an image view, a couple text views, as well as a linear layout. And this linear layout in turn has 2 image views as its children. Now you understand what a view hierarchy diagram is. By sketching out the diagram for each of these XML layouts, you'll better understand which view is the parent view, who the children are, and whether those children have children views or not. If you still need a hint, here are some examples of how to go from XML layouts to drawing a view hierarchy diagram. In this layout, we have a root view of a linear layout. By the way, I added these dots here because I couldn't fit all the code here. With a root view as a linear layout, you draw that at the top of the tree. And then it contains 2 children text views, so you draw those as children underneath that. And that's it. This is a more complicated layout. We have a root view that's a linear layout, and it contains 3 direct children, 2 text views, and a relative layout. And then inside that relative layout, we have an image view and a text view as children. When you're done drawing out the view hierarchy diagram for each option, then go ahead and check these boxes to continue. In the following quiz, I'll ask you to make a selection on which option is best, but for now, you don't have to make a decision. I'm going to draw out the view hierarchy diagram for options A, B, and C. We'll start with option A. It contains a linear layout as the root view, so let me draw that. Then I want to figure out the next layer of the view hierarchy, which would be the direct children of this linear layout. I'm going to scroll through the XML file to figure out the direct children of this linear layout. We have a text view, a linear layout, another text view, and then a button. So let me draw that in. Cool, that looks good, but we actually skipped over a bunch of XML related to this linear layout. This nested linear layout contains a button, a text view, and a button. Let's draw those in. This is the view hierarchy diagram for option A. At a high level, there is a parent linear layout as the root view. It contains 5 children views, and one of the children actually is a linear layout that contains 3 more views. Great, let's move on to option B. In option B, we have a parent linear layout as the root view again. Now we can figure out the direct children of this linear layout. We have a text view, a linear layout, another text view, and a button. This nested linear layout also has more children. We have a button, a text view, and another button. Hopefully, you're getting the idea of how to read an XML file by looking at the outermost parent first and then going inwards from there. And last but not least, we have option C. The root view is a linear layout again. Let's look for its direct children. We have a linear layout, followed by a text view, and a button. Okay, good. So this is the view hierarchy diagram for option C. This looks a little bit different than the other options, so let's compare them side by side. Here are all the options side by side. A and B have very similar view hierarchies, whereas option C has a different view hierarchy. This linear layout has only 4 children, as opposed to 5 children in the other cases. Also, since A and B look very similar, we're going to have to look more closely at the XML to determine what the difference is between the two. In the next quiz, you'll look more closely at the XML for each option. Then I'll ask you to decide which option you think best accurately describes the layout that we want to build. With the pen and paper still in your hand, go ahead and sketch out what each option would look like on a device. You can refer to the view hierarchy diagrams that we created in the last quiz if that helps you. Also, as you're reading through each XML file, make sure that you read each attribute carefully so you don't miss anything. When you're done with those 3 sketches, I want you to decide on which option gives you the desired layout that we want. These are radio buttons instead of checkboxes, so you can only pick one. Good luck! I'm going to draw out the different options for you. For option A, we have a vertical linear layout as the root view. So I'm going to draw a big old rectangle. And I'll keep in mind that as I add views to it, it needs to be added in a vertical column. The first child is a text view that says quantity, and it's in all caps because it's a header. So let me draw that in. Next, we have a horizontal linear layout. I'm going to draw it over here and add children horizontally. The first child of this linear layout is a minus button. So I'm going to draw that here. The second child of this horizontal linear layout is a text view that has the text to in it. The third child is a plus button. So I'm going to add that here. All these children are added horizontally, and this whole horizontal linear layout is a child within this vertical linear layout. Next, we have a text view that says price, and it's in all caps. It's followed by another text view that says $10. And lastly, we have a button that says order. Nice, that actually looks like what we want. But we'll hold off on any judgments, and we'll keep looking at the other options and sketch them out first. For option B, remember that the view hierarchy diagram was very similar to option A. By looking at the XML more closely, let's see if it actually looks the same on the device. We're going to start with a horizontal linear layout as the root view. As I add children, I'm going to have to add them horizontally here. The first child is a text view that is the quantity header. So let me draw that in. Next, we have a nested linear layout with orientation vertical. I'm going to draw that right here so it comes horizontally after the quantity text view. And as I add children to this linear layout, I'm going to add them vertically as in a vertical column. The first child is the minus button. So let me draw that. Below that, we have a text view that says to, and below that, we have a plus button. That finishes this nested linear layout. We also have a price text view, the $10, and also an order button. Taking a step back, this doesn't quite look like what we want. So I'm going to take a wild guess and say option B is not the correct answer. Let's move on to option C. Option C had a very different view hierarchy in that it only had 4 children under the root parent linear layout. This parent view is a vertical linear layout. That means the children will be added vertically one after the other. The first child is a horizontal linear layout. That means I have to add the children horizontally one after the other. The first child is a text view that says quantity. Then I have a minus button, the text that says to, and a plus button. That also looks funny, but we'll keep going. After this plus button is the closing tag of the linear layout. So after that, these children are part of the vertical linear layout. So this price text view needs to go vertically underneath this horizontal linear layout. The price text view and the order button are also part of the vertical linear layout, so they need to go underneath the price. And this is what the layout looks like. As you can see, this quantity text view has been made a child of this horizontal linear layout. So the quantity picker is showing up here, but also the quantity header. This difference in layout is all because we moved the text view to have a different parent. In the screenshot of the desired layout, we have the quantity header on top of the quantity picker, not beside each other. So we need to move this quantity text view to be a child of this vertical linear layout and not a child of this horizontal linear layout. Here are the sketches side by side. Clearly option B is not what we want, and option C is correct except for the fact that quantity and the quantity picker are in the wrong spots. They should be on top of each other. That leaves option A, which does actually build the desired layout. Whew, that was a tough concept, but you handled it really well. This unlocks the ability to build some really awesome layouts in Android, because almost all screens contain some type of nested layouts, which Kirill was actually mentioning earlier in the Google Play app. After all of that prep work, now we're ready to go back into Android Studio Land to implement the changes for an improved quantity picker. In case you're wondering, Catherine, what if I'm trying to build a layout and I don't have 3 options of XML layouts magically appear before me that I have to choose from? Well, that's a fair question. So far, we've practiced being able to read XML and draw a view hierarchy diagram. We've also practiced reading XML layouts and drawing a sketch of what the screen would look like. But now it's time to practice seeing a design of what we want to build and being able to write the XML from it. I do realize that I gave you the solution XML in the previous quiz. I was somewhat paying attention, but I don't want you to look at that solution. I want you to practice the skill of seeing a screenshot or a mock of what you want to build and then being able to write the XML for it. Normally, we would start with the desired screenshot of what we want to build. You could get this from a designer that's working on your team who's designing the app for you. Or if you're working without a designer, you could also sketch this out on your own. Then you would imagine how to break this down into views and view groups. You can mark it up and then try to draw out the view hierarchy diagram for the relationship between the children and the parent views. After you finish this diagram, you can start writing out the skeleton for what the XML layout code would look like. I'll leave these parts as an exercise for you. You'll make your changes in the activity main XML layout file. Aside from writing your XML here and seeing a preview of it, you can also click on the design pane here. This is the design tab as opposed to the text tab. The design pane allows you to drag and drop views onto the device. You can also see the component tree in the top right corner here. This is essentially a tree of all the views in your hierarchy. Currently, we have a vertical linear layout, that's the parent view, and all these children views inside of it. If you had nested view groups, they would also show up here. Now go ahead and build this layout in Android Studio. After you've selected and positioned the views, remember to style them so it looks like this. The style of the views is mostly the same, except note that there's 8 dips of space in between the minus button and the 2, and in between the 2 and the plus button. As mentioned earlier, avoid looking at the code and try implementing it yourself. When you're done, check this box to continue. First, I look at the screenshot and decide that since the views are in rows, it looks like a vertical linear layout. The second child, though, is not a single view. In fact, that's a horizontal linear layout of 3 views. This is what the view hierarchy diagram would look like. We have a vertical linear layout as a root view, and then 5 children under that. The linear layout itself has 3 children as well. Once we have the diagram, it's easy to create the skeleton of XML code now. The root view is a linear layout, and it contains a text view as its first child, followed by a linear layout, which has a button, text view, and button inside of it. And this is the closing tag for the linear layout. And then we have the text view, another text view, and a button, which are all children of the parent linear layout. From this XML, we can go into Android Studio and modify our existing layout to look more like this. In Android Studio, I open up Activity Main XML layout file. We're going to make the changes in place in this file so that they match more closely to our desired layout. The first child is a text view that we already have, and it's supposed to be the quantity header. Next, we should have a nested linear layout that contains 3 views inside of it. We don't have that yet, so let's add it. I'm going to hit enter and then just start typing linear layout. It also shows up as one of the autocomplete options, so I can just hit OK. Then it auto-populates attributes that I should fill in because width and height are required. I set the width to be match parent, which will in turn match the width of its parent, and this will match the width of the screen. For layout height, I don't want to set match parent, otherwise it will push the other views off the screen vertically. So I'm just going to say wrap content here. That way the linear layout will only be as tall as the 2 buttons and text view inside of it. Now this closing tag should be moved after all the children of the linear layout have been added. So that will go down here. When you have children inside of a view group, you should indent the children by 4 spaces. I'm going to add a space here too because I like to have a blank line in between each XML element. Oh, one more thing we're missing is setting the orientation of this linear layout. Earlier we decided that the linear layout should be horizontal so that the buttons and the text view appear horizontally. Cool, now that matches what we wanted. Next we have 2 text views and a button, which we already have in our layout. So I think we're done. If you wanted to check the design pane, this is what it would look like. We have a vertical linear layout with 5 direct children, and this linear layout has 3 more children. Let's run it on our device to see what happens. So this looks close to what we want, but not quite. The quantity picker is appearing horizontally, which is a good sign, but we want the minus button on the left-hand side and the plus button to be on the right-hand side, as shown in the screenshot of the desired layout. Also, these buttons are tightly squeezed up against the edge of this text view. If I remember the screenshot correctly, we also want 8 dips of space on the left-hand side and right-hand side of this text view. So let's add that now. Going back to the XML, I'm going to move the plus button to be after the text view, and then move the minus button to be before the text view. Okay, so in a horizontal row, we should have the minus button, followed by the 2, followed by the plus button. We also want to add padding around this text view. We could either add it as margin or padding, but I'm just going to choose padding. And we'll set the value to be 8 dips. Okay, great. Now I have a hunch that there's a bunch of extra white spaces and the ordering of our attributes may be incorrect according to the Android code style guidelines. So in the menu at the top of your screen, click on Code and then click on Reformat Code and also Rearrange Code. And that should rearrange all the attributes and fix up all the formatting for you automatically. Okay, great. Let's run the app again. There, that's better. Now there's space around the 2, and the minus button is on the left-hand side, and the plus button is on the right-hand side. Woohoo! It looks good. And let me also check that it still works. So I'm going to pick an arbitrary quantity, and then order. And that looks correct. Phew, that was a long journey to get this quantity picker on the screen. Alright, the app is looking really good. But so far I've only showed you how to show numbers on the screen. What if you want to show text on the screen? Keep watching to find out. So far we've built a quantity picker.
Right. And the next place to go in the app is the price.
Yes, the price is right. So the price is an integer so far, but we want to move beyond that and use strings.
You mean this type of string?
No, I mean like this type of string.
Huh.
So a string is just a sequence of characters.
So wait, how does this work with the price then?
So we're going to change the screen so that it says total and then $15. So it's not just a number, now it has some text with it as well.
Numbers and text.
Yeah, isn't that awesome? This is from the party that you may or may not have been invited to. Over the next few videos, we'll talk about using strings in our Just Java app. Specifically, we'll learn how to create and update string variables in the app. Then we'll change the app so that under the price header, it says total $15 or whatever the price is based on the quantity ordered. We'll also show the text thank you because we're excited about having any customers at all. You might be wondering why don't we just put all of this text inside the XML layout? Well, we could, but the problem is that the quantity can change, and when we hit the order button, we want the price to be updated here. So this text needs to accurately reflect the price based on the quantity. By using a string variable, we can change the value of the text while the app is running, without having to hard-code it into the whole XML layout. Here are some examples from real apps that you may recognize. When you receive an incoming call, you see the person's name at the top of the screen. We can't put this name directly into the XML layout because it'll change depending on who calls you, unless all your family and friends are called Britta Holt. The best thing to do is to store this name in a string variable. That way you can update it depending on who calls you. Then when we show this screen, we can just display the latest name that is stored in that variable. In the News and Weather app, we see a list of the top news stories. When we build the XML layout, we can't just specifically hard-code these specific news stories into the XML layout. As much as I love reading about the Winter Olympics, I do want to see other news articles as well. So we can store the information for each news story, like the article title, as a string variable, because that can change. For the next task, I'm going to provide you with some code, and I'm going to have you make those changes in your app. Then you'll run the app, and then observe what happens. I'll ask you some questions to see if you can try to figure out what's going on. The first change is to modify the submit order method. You can remove the code that's already in between the opening and closing braces, and then replace it with these 2 lines of code. Adding this code will give you an error, so I want you to also add the display message method, which we've provided in the instructor notes. In the instructor notes, you'll find this gist of code. Go ahead and select the whole thing, from the comment all the way to the last closing brace. You can treat this method like a black box. You don't have to worry about what's going on inside of the method. You just need to know that you want to add it to the main activity so that you can use it. Back in Android Studio, in the main activity Java file, I'm going to paste in this new method. I can paste it anywhere in the main activity, but I'm just going to put it right after the display price method. And I'm going to put it after the closing brace of the display price method. Notice that it's also inside of the closing brace of the main activity. The main activity has an opening brace right here, and everything inside of it is contained within the main activity. And then we have a closing brace for the main activity here. Once we've added the display message method in, we can now modify the submit order method. I'm going to erase the code that we already have inside the submit order method. Then, according to the quiz image, I'm going to add the new code here. Intentionally, I'm not giving you too many details on what I just did. I want you to try it out in your version of the app, run it, and see what happens. After that, I want you to answer these questions. What happens when you click on the order button in the app now? If you take a look at this submit order code more closely, we actually created a string variable. Even though we haven't gone over the code for string variables, I want you to make your best guess as to what do you think the variable name is and what do you think the variable value is. When you're done, go ahead and continue. At this point, you should have modified the submit order method and also added the display message method within the main activity. Then you can hit run to see it on your device. First, I'm going to change the quantity, and then I'm going to hit the order button. Now the app says free for price. That answers the first question. When the order button is clicked, then the price text field now says free. For the second question, we talked about creating a string variable in this submit order method. Even though we haven't seen code for a string variable before, I asked you to guess what you think the variable name and value would be. The answer is that the variable name is price message and the value is free. To arrive at these answers, let's look more closely at how we create string variables. Earlier in the lesson, we learned about how to declare or create an integer variable. We're going to follow the same format to create a variable, but this time the variable holds text because it's a string. This is the code we added to our app. This creates a new string variable called price message, and the value that it holds is the text free. It follows a specific format according to the syntax rules of Java. First, we specify the data type. In this case, it's a string. Remember that a string is just a sequence of characters. Then it's followed by the variable name, which is price message in this case. Then it's followed by an equal sign, the initial value, and a semicolon to indicate the end of the statement. Saying that the data type is a string limits what type of information can go inside this variable. Only one string can be stored in it at a time. A string can be made up of letters, numbers, or symbols. You may recall that a variable name is the name that we give this variable, so we can refer to it later to get the value out or to update the value. It's like giving the variable a name tag. When you're picking a variable name, it's important to choose something that's descriptive, that describes what type of information it will be holding. I could call this variable name Catherine, but it really does not reflect the information inside of it. It makes my code harder to read as well because no one knows why there's a string variable called Catherine. On the other hand, a variable name like price message is a little more helpful because you know there's a message inside of it that's related to the price probably. We looked at this earlier, but there are naming conventions for variable names. If you forget what those are, you can always look them up. I just search for variable name Java in Google search. I can scroll down here to where it talks about naming. It says that variable names are case sensitive and you usually start with a lowercase letter, and then you use camel case if there's multiple words. Next, we have the assignment operator, or the equal sign here. This operator is in charge of assigning a value to a variable. So you take this value on the right-hand side and you assign it into the variable price message. We specified the initial value of this string to be some text in double quotes. This is called a string literal because a literal has a fixed value. We first heard about literals when we were learning about integer variables. A fixed value like 2 or 5 or 10 are all integer literal values because they don't change, as opposed to a variable which does change. Going back to our box analogy, the value free would go inside this variable. And last but not least, we also have a semicolon at the end of the statement. Now that we understand this line of code a little better, go ahead and try to experiment with different values. You can try to change the initial value here or change the variable name. For example, you can use a short string like free or change it to be a longer string. You could make it a completely empty string as well, which leaves no characters in between the two quote signs. You could add a space, or you could add numbers as well, or you could add symbols. When you're creating your string literal, Just be careful that there are certain characters that you need to deal with specially. For example, if you use the quote sign in your string, then you're going to run into an error that says can't resolve symbol dollar and a semicolon is expected. This is because the compiler doesn't know that the whole string is supposed to be this whole thing. To solve this problem, let's do a Google search. We can Google search for Java escape characters. And scroll down to a section called escape sequences. In Java, certain characters mean special things. The start and end quote symbols are to denote a string in Java. But if you want to actually put a quote inside your string, you'll need to use an escape sequence. An escape sequence is a character preceded by a backslash, and the Java compiler will interpret it in a special way. If we use a backslash with a double quote, that indicates that we actually want to use the quote symbol, not the quote that means it's a text string. Let me show you what I mean. In Android Studio, I can add a backslash before each quote mark that I actually want to appear in the text. Now the whole initial value of this variable will be this whole string because it's marked off by the start and end quotes. And inside that text string, I also want to use quotes, but I mark those by using a backslash in front of each quote. If I run on my device, I see the quotes around $1, but I don't see the quotes around the full thing, which is what we expect. Another useful escape sequence to know is this \n, which inserts a new line so that the text will continue on to the next line. You can try this one out in your code as well. Remember that the semicolon should always be at the end of the statement. Even though in English it's grammatically correct to put the punctuation inside the quote, you want to put it on the outside of the quote. Anything in between here is part of the text string, and you need to put the semicolon on the outside for the Java compiler. You can also modify the variable name. If I change this to something like message, then this gives me an error here because it can't resolve the symbol price message, so I just need to copy it and put it down here as well. And this should run on your device. You can't change the data type though. It must be spelled string exactly like this. String is capitalized here because it's an object. We'll learn about objects in lesson 3, but for now just type string with a capital S. When we were working with integers earlier, we would declare integers with a lowercase I for int. It's lowercase because it's a primitive data type, where primitive means it's one of the basic Java data types. Experiment with different variable names and initial values until you're comfortable with creating string variables. Then I want you to tell me what's incorrect about each of these string declarations listed below. I want you to point out the error in each of these lines of code. I asked you to determine the bug in each of these lines of code. Hopefully you were able to do it by just looking at that line. For this solution video, I'm going to enter these lines of code into Android Studio so that you can see what error Android Studio would give us, and we're going to fix it as well so that there are no errors. I temporarily commented out this line of code using the // so that it doesn't show that there's a red error every time. We'll switch back to the code we had before, but I just wanted a place where I could add these test strings. If I type in string title equals today's specials, I get an error. It says that it can't resolve the symbol string. That's because Java doesn't recognize the type string with lowercase s. It needs to have a capital S. Now it recognizes this data type and there's no errors. There's an error on the second line, but I'm going to comment it out with a //. That way the computer won't try to compile that line. Technically this string isn't going to go into our app, so we don't need it to work with the rest of our code. If I type in special of the day equals cafe latte, I also get an error. It says cannot resolve symbol special of the day. That's because this variable was not created earlier. This is the first time we're using it, and so we need to specify the data type in front of it. So we'll say string special of the day equals cafe latte, and that fixes the problem. Now I've typed in string nutrition info equals 500 calories or less. Under the string here, I get a red underline that says illegal line end in string literal. I was trying to create a string literal here, but I forgot the end quote, so we need to add that. And that fixes the problem. The last one is string drink name equals iced coffee. The word name is highlighted in red, and I get an error saying it cannot resolve the symbol name. The reason is because a variable name should be in camel case with no spaces. So I need to get rid of the space here, and if there's 2 words, you can just capitalize the beginning of the second word. And that fixes the error. For the name of the drink, you might want to capitalize the I or the C here, but it's really up to you. Anything you put in the double quotes is your choice, and the Java compiler won't complain about those types of errors. Great, you've really mastered how to create strings in Java now. When dealing with strings in Java, an important concept to understand is string concatenation. Now that's a really big word, but it just means we're joining character strings together end to end. If this is a string and this is a string, you can combine them by concatenating them to make an even longer string. To concatenate these strings together, we use the plus operator. This is the same addition symbol that we know from math. Just like you can add numbers together, you can concatenate strings together. Let's look at an example. Say I have 3 different strings. One string literal says I need, another string literal says 2 cups of coffee, and another string literal says on Monday. I can use the plus symbol to concatenate all these strings together. That forms a ginormous string that says, I need 2 cups of coffee on Monday. Whenever I see something like this, I imagine the plus symbols are gone, and I imagine the quotes are gone, and I just imagine literally squishing all of these things together. And when I say squished, we're really squishing them together. There's even no extra space in between this string and this string. If you want to add a space here, you would have to explicitly add a space in this string literal at the end of it, or you add a space at the beginning of this string literal. Same with coffee on Monday. I want a space here, so I'd have to either add it at the end of this string or the beginning of this string. I added a space here and a space here, so when I concatenate all of this together, I squish them together, and the sentence comes out correct like this. There's a space here and a space here. Adding spaces in the right place is a little bit tricky because you have the quotation marks everywhere and the plus symbols, and there's even spaces around the plus symbol. But these spaces around the plus symbol don't contribute to the overall display string. The space must be inside the double quotes. Here's an example of string concatenation in our app. I'm going to change the text so that it says amount due plus $10. I'm concatenating this string literal with this string literal. When I run it on my device and then I hit the order button, then I see amount due $10. You can also concatenate strings with integers, like I have here. Before, the 10 was in quotes, so that was a string representation of the number 10. But here I just have 100 without quotes, so this is the integer value for 100. If I concatenate a string with an integer, then it immediately turns this whole thing into a string. If I hit the order button, then I see $100 showing up on the screen. In a moment, I'll have you play around with string concatenation to try different values. You could get compile errors, so be careful of those. If I forget a closing quote, I could get an error. In a moment, I'll have you play around with string concatenation and try different values. According to Android code style guidelines, we should have a space before and after each operator, and this string concatenation operator counts as an operator. Now it's your turn to practice in your app. Experiment with combining different strings using the plus operator. You can also combine it with integer literal values as well. Once you feel comfortable with string concatenation, I want you to answer these questions. Let's go over the answers to these quiz questions. Each of these lines of code creates a string variable, and I wanted to know what is the value that goes inside the string variable. That means we need to evaluate this expression, which includes string concatenation. Part A says string order number equals order number semicolon 23. The value that gets stored in this variable is order number semicolon 23. Notice that there's no space after the semicolon because the end quote is right after the semicolon. Since this is a string literal concatenated with an integer literal, then the whole thing just turns into a string. For part B, the right-hand side of the equal sign evaluates to the string, you were served by Jack. There's a space here because there's a space right before we have the end quote. For part C, this string evaluates to, you're 2 cups away from a free drink. The number 2 is an integer literal value here because it's not in quotes, it's just a plain number 2. Since we have an integer concatenated with a string, it just becomes a string. And all these parts are combined together. So we pretend to squish them together, and that's why there's no spaces right here. Because there's no space after the R, and there's no space before the cups, so our 2 cups is all combined with no spaces. In the last video, we saw how we can take string literals and combine them with integer literals using the concatenation operator. This expression evaluates to the string, I need 2 cups of coffee on Monday. The powerful thing about concatenating different parts of the text together is that you can swap out different parts if they need to change. For example, the number of cups of coffee might change. So instead of a literal value here, we can change it to be a variable. Now I've removed the 2 and replaced it with a quantity variable. So when we evaluate this expression, we'll always get the latest value of the quantity variable. If the variable is holding the value 2, then it'll pronounce something like, I need 2 cups of coffee on Monday. So these parts of the string stay constant and they don't change, whereas the quantity is free to change and we'll always get the latest value. I'm going to try it out in Android Studio. Since quantity happens to be a variable that we already have declared in the main activity, I can just use it directly in submit order method. I'm going to make up a string like total item count and then add quantity and then coffees. This isn't really related to price, but I just want to show you that you can concatenate strings with variables. Let's run this to see what it looks like. If I change the quantity and then hit the order button, then it shows total item count 3 coffees. I forgot to add the space right after the 3 but before coffees, so we should go and add that in. I'm going to add a space here so that it appears right after the quantity. Notice that quantity here is not in double quotes. If it was, then it would literally show quantity on the screen, but we want the value of this variable, so we don't put it in quotes. Now that it has an extra space here, let's try to run it and make sure it's correct. Now when I change the quantity to 3 and hit the order button, it says total item count 3 coffees. It correctly has a space before and after the quantity value. Taking a step back, when you look at this line of code, it can be a little overwhelming because there's quotation marks everywhere and plus signs and spaces in weird places. Just imagine that the plus signs disappear and everything in the quotes gets squished together and that the quantity variable gets replaced with an actual value. Because it's not that easy to read, it's common to have mistakes here. You might miss an opening or closing quotation or put the plus in the wrong place or accidentally put a variable in quotes. Just read through your code carefully to make sure it's doing what you expect. You can also do math expressions. You can have quantity times 5 in parentheses, and this will turn into a single integer value, and that will get concatenated to price. A string plus an integer turns into a string, and that gets stored in the variable price message, and that gets displayed on the screen. When I run this on my device, it shows up as price 15. If you want the $ or the currency symbol to show up, you need to make it part of the string literal, like this. The integer only holds the number part, not the currency symbol. If I run this on my device and then hit the order button, now I see the currency symbol. Following the pattern that I've been showing you, go ahead and modify the submit order method so you can practice displaying different messages on the screen. First, try to display amount due $10 on the screen when you hit the order button. Once you get that working, then change it so that you display this string when you hit the order button. Repeat the same for each of these different strings. You should only see one of these strings on the screen at one time. Remember to concatenate the strings with variables so that the quantity and price values are accurate based on the quantity picker. So if I change this to quantity of 5 cups of coffee, then the amount due should be $25. First, I'm going to change the app so when you hit the order button, it's going to show amount due $10 or whatever the price is. Since there's going to be a lot of combinations where I'm going to need the price, I'm just going to create an integer variable to hold the price. Notice that the int is lowercase I because it's a primitive data type. Now I can just refer to the price variable whenever I want the price number. Now I need to change the string so it says amount due. So I'm going to write amount due, add a space, and then concatenate that with the price variable. Oh, and I forgot the $sign as well. The $sign should be part of this string literal, and I want it to be after a space, so I'll put it right here. Now I'm going to run it. If I change quantity to 3 and then hit the order button, then it correctly shows amount due $15. First one done, that wasn't too bad. Next, we want it to say that would be $10, please. I'm going to change this text to start with that would be, and then I want a $sign, the price, and then I want some more text after that. I should say please and a period. I add a space here because I want a space after the price. Let's check to see what that looks like. On the device, if I change quantity to 3, hit the order button, it says that would be $15, please. Now the second one's done. We're on a roll. The third one says, you owe $10, dude. I'm going to change the start of this string to be you owe, and then I'm going to remove the dollar sign because we just need the price. And then we're going to add bucks, comma, dude. That looks correct. Let's run that. When I hit the order button, it says you owe $15, dude. The fourth one is a little tricky. We want to say $10 for 2 cups of coffee, pay up. I see a need for 2 variables here, the price variable and the quantity variable. We're going to start with the price, which is 10, and then we're going to say dollars for, and then I need to put the quantity, and then cups of coffee, and then pay up. Let's run that. If I hit the order button, then it says $15 for 3 cups of coffee, pay up. That looks really good. This was tricky because we had 2 variables here concatenated with 2 string literals. Fortunately, we added spaces in the right place so that it would look like a normal sentence. That was the hardest one, and now we can do the last one that says total, $10. I'm going to erase this whole thing here and say total, space, and then the price. Oh, but I also need the dollar sign, so I'm going to put that inside the string literal. Oh, and I forgot the plus sign too. There. Now let's run the app. If I change quantity to 3, hit order, then it correctly says total, $15. Woohoo! You got through all of these different combinations of string concatenation with variables. Now move on to the next video for your last coding task of this lesson. Just like you can change the value of an integer variable after you've created it, you can also change the value of a string variable. You can update it to a completely new value. In our Just Java app, say we wanted to display a special drink of the day. Then we could use a string variable to store the name of that drink. Here we declare a string variable called drink of the day, and we initially set it to the value latte. With our box analogy, this is what it would look like. We have the latte value stored inside this variable. On another line of code, we can say drink of the day equals a new string value. Now the word espresso is stored in this string. We don't need to specify the data type string again because it was already declared as a string up here. On the next line of code, if we say drink of the day equals green tea, then we store green tea into this variable now. Here's another example where we might want to display the store hours within our app. We can create a string variable to store the text that should be displayed on the screen. The initial value is open today from 8 a.m. to 5 p.m. On a different day, we can update the string variable to say open today from 8 a.m. to 2 p.m. because we want to leave early to go to the beach. Or on another day, we can update the store hours to say closed today because we don't work on Sundays. If our app had a running list of all the drinks that the user wanted, then we could create a string variable called drinks ordered. We could start it off with one drink, like one mocha. In the variable, we would store the text one mocha. And then if the user wants another drink, then we can just concatenate the new drink onto the existing drinks ordered. This gets stored inside the variable drinks ordered like this. If I want to add another drink, I can just concatenate that onto the existing string drinks ordered. This expression evaluates to one long string that says one mocha, one cappuccino, one macchiato. All of that gets stored into this variable, like this. It might look a little funny to have a comma and a space at the beginning of this string, but that just makes the list look nice with commas in between each item. The reason why I didn't put a comma at the end of cappuccino is because I can't be sure if there's going to be another drink coming after that or not. If there's only 2 drinks, then it will say one mocha, comma, one cappuccino, and that looks fine as is. If there's another drink coming, like a macchiato, then I can just add a comma because I know another drink is coming. Go ahead and try this out in Android Studio. Add another line of code that updates the string variable to a new value, or you can update it to the current value plus some more stuff. Once you're comfortable with knowing how to update string variables in Android Studio, Then go ahead and implement this final behavior in the app for lesson 2. When you change the quantity and hit the order button, it should say total and the price, and then thank you. Technically, you don't need to update the string variable in order to build out this functionality. However, I'd still like you to do so if you can. In the next lesson, you're going to need to update string variables more often, specifically because there's going to be more fields in this order form, and we're going to need to build up the order summary. When you're done, check these boxes to continue. This is the last coding task of the lesson, so good luck. So far, the message already says total, and the price, and we just need to update it so it also says thank you. I'm going to update the string variable because I want to practice that. So I'm going to create a new line of code that updates the price message. And I'm going to just add on to whatever's in the price message string. And I'm going to add thank you. Let's run this on the device. Okay, if I change the quantity and I hit order, then it says total $15, thank you. And it all runs together without any spaces. But the thing is, I don't really just want a single space, I really need it to go on the next line. If you remember earlier in the lesson, I mentioned escape characters in Java. Escape sequences are a character preceded by a backslash, and it means something special to the Java compiler. Before, we used it to insert a double quote in a string. Now we can use it to insert a new line in the text. In the code, I'm going to add a \n so that it creates a new line right before it says thank you. When I run the app and change the quantity and I hit order, then it says total $15, and then it adds a new line, and then it says thank you. Yay! And thank you for doing all the coding tasks in lesson 2. So our students have been learning about variables and data types in this lesson, particularly about integers and strings. Are there examples in the apps that you've worked on of these things?
Oh yes, there are plenty.
Okay.
So strings or integers are everywhere. In Gmail, for example, when you first open your email, it tells you how many unread messages that you have. So that's a very, very important number. And we actually have these very subtle bugs that the one number might not match exactly how many unread messages you have. So
I've never encountered that, have you?
That's good that you never encountered it. So yeah, but these are, it's an interesting problem to solve because for Gmail, we actually sync that number first. Like sync means like I'm fetching my data from the cloud to my Android device. So that data is actually, that number is synced separately from your actual email. So they could potentially go out of sync. And that's one of the very trickier issues to solve.
Okay, so we've established that the number of unread emails is a variable. Its data type would be?
It would be an integer.
It would be an integer.
Yes.
And its value is being calculated across devices, and its value is changing based on the use case or the scenario a user is experiencing.
Yes, exactly. And another use of integer, so that's an example of a variable integer. Basically, it could change. Another example is IDs. So for IDs, it's actually very important that the integer stays the same.
So my email ID particularly.
Exactly.
Okay.
So the email ID on the server that represents that email needs to be exactly the same as the ID that's on the client, because that's the way we uniquely identify this email everywhere across all your devices.
So this is for a conversation email, not like an email address.
Yes, for a conversation. So in Gmail, for example, the whole thread, so the email thread, which has multiple messages in it, the whole thread we call a conversation that has a conversation ID. And then each message itself also has its own unique ID.
Okay. And each one of these IDs is stored in a variable whose data type is?
Integer again.
Okay.
Yes.
How many emails are going out in a day? Do you know? Like, this is a lot of numbers.
Yes, I do not know on top of my head how
But
many emails.
I'd imagine that if each message in a conversation is unique, and each email is unique across all emails that are going.
Yes.
This
So
has got
that's-
to be a very large number, right?
So that's a very good question. So instead of an int, actually, for these we use longs.
Okay.
So it's because it's 64-bit instead.
Okay.
So then we will never.
So
it's
long
guaranteed-
just gives you more space to hold a larger number. That's really the
Exactly.
difference between int and long. Okay.
How about any strings?
strings.
I'd imagine, is subject a string at all, or how is that stored?
Yeah, everything. Yeah, subject is a string itself.
Okay.
And obviously, email addresses are strings, so that's another very important. And almost everything that you see in any app, like visually everything that has text, would be a. And I think a good engineer, you don't have to know everything, but you have to be good at like figuring out, like know where the answer. You can probably look for. There's a lot of good tutorials out there for. Just have to know how to look for the right keywords, search for the right keywords.
Yeah.
And you also ask people for help.
Oh yes, that is actually very important. I think almost always I regret not asking people earlier. You know, I could like try to fix something for like a whole day, and at the end of the day, decide, okay, maybe I should have asked whoever wrote this component. So yeah, like I think reaching out to people early is definitely valuable, can save very valuable time. And also just being more aware of what other projects are going on at Google. I think or you know, at your own, around you. I think the really good engineers, they not only focus on what they're doing, but you know, we have these things called tech talks at work. So
Which are available publicly for people to view, at least some of them
yeah,
are.
some of them are, yes. So they often know what the latest technologies are, you know, from these tech talks or announcements that are, you know, sent to the entire engineering org. So just being on top of.
And let's go back to the time when you were actually learning to program. If you could talk to the Alice at that time, what advice would you give her today?
Wow, that's a very interesting question. I feel like I should have had more fun with programming. So I think the way I learned to program, and I think it's very different now, because I grew up originally I'm from China. So I think it was very academically focused. Like, you know, I went to these extracurricular, you know, classes that like taught by a teacher, and then, you know, we get assignments like, you know, learn this algorithm, and then, you know, solve this problem. So, and I think looking back, I wish I had like done more projects, or just like fun type projects. And I think
Would you make a birthday app?
a birthday app. Oh yes. Yeah, like exactly, like, you know, these type of apps that I could have. I think I could learn a lot more, because it's not just about, you know, oh, there's this one right answer. But in like doing an app like that, I can learn like about design. If it's a birthday app, I'll learn about, you know, different UI components. It's not just about, you know, okay, you need to send this data from here to here, and then, you know, solve it more efficiently. And I think it would, and I think in real life, that is what, you know, engineering is more about. Is about, you know, not just solving a technical challenge, but also creating a great product.
Yeah, sort of like being driven by your own curiosity.
Yes,
creating
exactly.
things.
Yes.
Well, Catherine and I want to thank you for your time.
Oh,
Alice.
you're very welcome.
I think our students will benefit a lot from your perspective.
Yeah.
Our student just learned Java.
That's amazing.
It's huge.
It is huge. They also learned how to add a button on the app. Click on the button, something happens magically. It's called event-driven programming.
yeah.
You know it, we know it, they know it now.
Yeah, now they know it.
Yeah.
And we also learned about variables, which is what makes the quantity picker go up and down.
Correct. Alice, the Android developer, made a guest appearance.
Oh, yeah,
She
Alice.
was talking about how she gets unstuck when she comes across a bug.
Those
is-
are some good tips.
Right.
Yeah.
So, you know what that means.
We're basically done.
We're done with lesson 2.
You done with that?
I guess
Yeah.
Because
so.
we closed an hour ago.
Ooh,
Oh,
sorry.
sorry.
I'll take it from here.